Hello guys, what's up? And today we're going to be learning about how to get user input. Here we go. Int age, printf, enter your age. And then we have to say scanf, %d, ampersand age. So this is what happens with scanf. You have to specify what type of information you're expecting from the user. And %d means int. That means scanf is expecting an int. And then it will store whatever value it gets at the address of age. So you may be saying, why can't I just say age? Why do I have to say ampersand age? And here's why. When you send an int to a function, you send a copy. So if you change the copy in the function, it doesn't change the original in main. So if you were to say just age, it wouldn't be changing this age. It would just be changing the copy in scanf. So you need to say ampersand age so it changes the original. Yeah, the only way to change the original is to send a pointer to x to the function. The function then has the address of x and can access and change the original. Similarly, scanf needs the address of x so that it can access the original and change it. So yeah, that's why you have to put the ampersand right there. And let's actually try this out. Let's see. Printf your age is %d. Age. My bad. Printf. I am 19. Your age is 19. Amazing. This is amazing. Now let's try a char array. Char first name. Let's make it of size 4. And let's make a last name. But I'm going to make it Smith. We all have the last name Smith, okay? Printf. Enter your first name. Scanf. %s. First name. But no ampersand. No ampersand this time. And here's why. Remember that when you say first name, that you are essentially saying ampersand first name 0. The name of the char array is a pointer to the first letter. So up here we had the address of age, and that's a pointer. And when you say first name, you are saying ampersand first name 0, and that is a pointer. So this is a pointer on its own, so you don't have to put the ampersand. Now, printf, your name is %s, and you are %d years old. First name, last name, age. Let's test it out. Your age, 19, and I'm John. Totally, that's totally my name. Your name is John Smith, and you are 19 years old. Woo! And that's how you use scanf. But now, let's get into some technical stuff right here. Here I said that first name was 4 bytes big. So what happens if I try to write a bigger name? Enter your name, your age, 19. My first name is Thomas. it still works, Thomas Smith, and you are 19 years old. But that's not good practice. You usually want to make this big enough, like 25. But you may be asking, why does it matter if it works either way? Stop. When it's 4, it still works. Okay, here's the danger. Let's say these are the 4 bytes you have for Thomas. And then immediately afterwards in memory, you have other information like the person's a male and they're from Ohio. That's the beginning of Chicago. If you try to put Thomas in these 4 bytes, what will happen is that scanf will end up overwriting the next few bytes. And if there's information in there, you're going to lose it. So whenever you go like right here to try to print male, it's going to print as instead of male. It'll go AS, oh, \0, I'm done. So scanf can be dangerous, so you have to make sure you give them enough space to store their name. Like, who has a first name that's more than 100 letters? Nobody should. If they do, that sucks. So make sure you give them enough space. But let's make this 4 for now. And remember how our last name is Smith? If we make our first name long enough, it's going to end up overriding Smith. And I can show you. 19. This shouldn't do anything, but A, B, C, D, E, F, G. Your first name is all these letters, and your name is Smith. But now look what happens when you make your first name a little bit longer. 19. Your name is A to S, and your last name is QRS. So what we ended up doing was overwriting Smith with QRS\0. And that's why you have to make sure that you give the user enough bytes and space for their character arrays. So, yeah. That's it for this video.